here. Okay, now it's now recording. So welcome to today's class. We'll be going through allocation and deallocation. Okay, let me add this person. Yeah, so we'll be going through deallocation and allocation. So I need to talk about two important things, right? The stack and the heap. So I'm gonna open my notepad. So we have okay, it's just Java. We have two things, right, that we use. So these two things I'm about to talk about, stack and heap. You can think of them as like a storage area where you store your things. For example, you store cars in a garage, right? You park them inside the garage. So the garage is a storage area, right? Or a fridge. That's an area where you can store things, right? So when you create variables inside code blocks or inside C++, what happens is that it stores them somewhere. You can either store them on the stack or on the heap. So what is the difference between the stack and the heap? So the difference between a stack and heap, right? Stack, I want you to imagine it as like going to visit your grandparents, right? So this is your grandparents' house, right? That's a stack. It's your grandparents' house. Meaning that when you go visit your grandparents, you don't have to do everything. So most of the things that are going to be done there to be done for you, right? Your grandparents will do things for you. For example, you can tell your grandparents with you're hungry, then your granny can cook for you because that's how grandparents are. They're just so chilled, they're relaxed, right? So you can think of the stack like that. It's like your grandparents' place where things are done for you. They're done for you. So I'm gonna put this to demonstrate the stack and the heap. Then I'm gonna put this side to side, right? So this will be the heap. This will be the stack. So let me put in a label there. Then increase the font size. Right. Then I'm gonna give them a names, right? So this will be the stack. Like I said, you can think of this as like your grandparents' place, right? Or house when you go visit your grandparents. If you notice, your grandparents, they actually make you become a spoiled brat because they spoil you too much, right? Because they do things for you. So you don't have to do things on your own, right? So that's the point I'm trying to make. Then a heap is like your parents' place. When you go to your parents and you say, Mama, I'm hungry, they'll tell you, go cook, go cook. You have hands, right? Go cook. So that's like the heap. That's your parents' place. Everything is managed or is done by you. So when you use the heap, if we allocate and we deallocate, we do it ourselves. But if you create a variable on the stack, you don't have to allocate it, you don't have to deallocate it. It's done for you. So let's say you had a variable here, right? Let's say you have a variable here. So let me show you the difference, right? So I'm gonna open code blocks because I really want you to picture it. If you can picture it, trust me, the coding part becomes so easy. You even laugh at yourself for not getting it right. So I'm gonna create a console application, choose C++, then I'm gonna call it allocation, deallocation. Right? So I will send the code in the group. So I'm going to say view. So I'm going to send the code in the group in a zip file. So I'm going to zip it and send it in the group. So there's our code, right? So when you create a variable here, using any data type, let's say you create a number that takes in both positive and negative numbers. So a signed number. So I'm going to say signed int number or num, or just call it number. And then I'll initialize it to 20, right? And remember, the signed is optional because by default, when you leave it like this, it is signed by default. So it's fine. I'll leave the signed keyword because it is already signed. So it stores 20. So you see the syntax that I've used here, right? It doesn't matter whether you use the equal sign, even if you did this, it's exactly the same thing. So me, I prefer this syntax. So this is how it looks when it's initialized, right? This is what happens. We are telling C++ to create a box on the stack. How do I know the difference between the stack and the heap? The stack, you can see that something is created, a variable is created on the stack when you don't use these two keywords, new and delete. When these two keywords are not used, right, that means that variable is created on the stack. Because these two variables, these two keywords, they are used only when you're managing the memory yourself. So this is what happens. C++ creates a box and it allocates memory for it. By memory, I mean things like megabytes, gigabytes, kilobytes. That's what I mean by memory. It creates memory for that variable. So there's the variable. It has been created for you. It's like I said, we talked about variables. You can think of variables as like boxes. Then the name of the variable is the label on the box. So the label is number. So which means this box stores a number. Then I'm going to have a data type here, which is of type int, right? Meaning it can only, the things that can go inside this box are only integers. That's what that int means. That's what you're telling C++. So there's my box. I can put in only integers. Then this side, right, this part, this curly braces and that 20, I'm telling C++ to assign that box with the label number, to assign it or to put inside of it the number 20. So this is what C++ does. It takes 20, right? And then it puts that 20 into the box. So there's that 20 is inside the box, right? So yeah, I'd have to put it somewhere in there. Let me put this box a bit down. Yeah, this is better. So I've told C++ to put in that number right into the box. So let me give the box some color. Yeah, to give it life. So there's the box, right? So it's on the stack. How do I know it's on the stack? Because I didn't use the keyword new. If you want to allocate it on the stack, you have to do the allocation yourself and do the deallocation yourself. Allocation and deallocation, right? I want you to view it in this way. Allocation, think of it as like when you're washing, before you dish up food, right? I agree, you wash the plate. So you wash the plate, right? But then before washing the plate, let's assume that you found the plate was clean, then you dished up, right? Basically you put food onto the plate. So that process of putting food onto the plate, think of it as allocation. We are allocating memory for the plate. Then when you eat, right? And then the plate is finished, right? So once you are done using the plate itself, in this case, the plate is like a variable. Once you're done using the plate, then you clean it, right? Because why wouldn't you clean it? Unless if you're a very untidy person. You can't tell me that you're gonna eat tonight, then leave the plate there and you don't wash it. Then in the morning, you take that same plate that's not washed and then dish up and then eat in the same plate. No, that's impossible. Unless if you're a very untidy person. So you're obviously going to wash the plate, basically clean it. So deallocation is that's the process. That's the process of cleaning because we are no longer using that plate, or in computer science, it's variables. So we are no longer using that variable, so we clean it. Basically, we deallocate. So to allocate, just know is to dish up, to prepare it, right? To prepare that plate, putting food into it. That's us allocating the plate. And then once you're done eating and you're done using it, then we can wash it or deallocate. But then when you do everything on the stack, it does it for you. So C++, when it gets to line 7, it creates a box on the stack because you didn't use the keyword new. So it knows, oh, I must create it on the stack. Then there's the stack, there's the box. Then it puts the number 20 into the box. Then when C++ reaches this return 0 part, right? This tells C++ to, if there's things that are done being used, clean them. especially if they're on the stack. So it's gonna go to the stack and then it deletes this number 20. It deletes everything. It removes that label. It removes the data type, and then it leaves an empty box. So it has cleaned the box so that it's ready for use when you create another C++ app or you do another C++ practical. So that's the stack. It's managed for you. Things are done for you on the stack. Then comes this very troublesome thing called the heap, which is like your parents. Very troublesome, right? They'll tell you, no, you must go wash the dishes, you must go do this. But then when you go to your grandparents' place, your grand is gonna be like, do you want a snack? Do you want what? But if you're at home, they'll tell you no snacks. You're gonna become fat or you're gonna have diabetes. They tell you a lot of stories. So that's why we tend to I'm sure most of us tend to like our grandparents more. So that's like the stack. That's your grandparents' house, the stack. Then the heap, everything is done by you. From laundry to washing plates to what, everything is done for you. So if I'm using the heap, right? Whoever's unmuted, please mute. So if you're allocating on the stack, there's a difference. So let's see how to allocate on the stack. You declare the variable as always is normal, right? You put the data type to specify what type of things go into the box. Then you give the box a label or the name or the variable. Then you assign it, you give it a value. So I'm going to give it a value that I'm going to allocate into the stack. So I'm going to say new int. This is how you this is how you allocate a value into the stack. And then semicolon. So what you're telling C++, right, is you're telling it create a new integer or a box that's big enough to store an integer. But you see that we didn't give it that box a value. So for now, it's actually an empty box. So let me show you. So when you write the line of code, right, it's basically doing this. So let me delete this. So it's basically creating, so let me copy this box. So it creates a box on the heap because I've used the keyword new. So it stores the box or creates a box that's big enough to store an integer. So now this has to go this side. Oh, no, it's fine. No, it's fine. Yeah, it's fine. So there's the box. It has no name. You can't name variables on the heap. You can't. It's impossible. You just tell C++ what things you need. That's it. Then you store an address of that. So what happens, remember we talked about variables, that each variable it stays it's put into what we call main memory or RAM. It's placed there when you're running a C++ program. Then C++ reads the variables from there, from RAM. But when it's placed on the RAM, it is an address. So you can think of it as like drawers. There's one drawer after another. Each drawer has an address so that the computer knows which drawer to go to if you're trying to get a specific value for a specific variable. So we understood that part, right? That each variable has an address. It's stored somewhere. Just like you or Chomi stays at a specific place, right? That place is an address, right? So computers do the same thing. Each thing that's stored in a computer, it has its own address. So this box, right? C++ creates the box on the heap because you told it that you are using keyword new to tell you that you're gonna allocate it on the heap. So this is created on the heap. I want you to notice one thing, right? I use the keyword new, I use new int. You see, there's int, just int, which means that I told you to create one box to represent one number. If you want to represent more than one number, which is basically an array, after the data type, you put in square brackets, then you specify how many integers you want. That's the second way. But then for now, I'm just doing one number, not arrays. But then it's exactly the same concept. It's very exactly the same thing. So that's the new integer. So now you try to run this, you realize an error will occur. Why are we getting an error there? Because this is a variable. A variable stores numbers. Basically, actually, it stores values. Basically, it stores what's inside the box. That's what variables store. But then this line of code, this is what it does, this line of code that I've highlighted. It creates the box in the heap. then it returns an address of where the box is stored in the heap memory so that it's easy to locate that box. Remember, the box is no name. So how will you find it if we don't know its location? So therefore, after creating the box, you get back an address of where that box is stored in memory. Another word for address, right, or a synonym, if you remember high school synonyms, right? This is like your parents' house. Remember, if you remember synonyms, right? So, okay, let me, now I just lost my train of thought. I was talking about what new int create there. It has no name, it is an address. Yeah. So another word for address, right? Or a synonym for address, we say it's a pointer. That's another word for address, pointer. So that means that when you allocate memory, when you create a variable on the heap memory, it returns a pointer to that box. So since it returns a pointer, I need to declare a pointer to store that address. So I'm going to have to put a star there, an asterisk. And then if I build this, you see, no more errors because this part returns an address of where that box is. So this line of code, right? This is what happens. It created the box here, but then remember we told it to create the box on the stack. There's a box on the stack. It is the label number and it's a pointer. So int star. So it's a pointer. Then we get back an address of that box. So let's say the address of this box is, remember it uses hexadecimals. So let's say the address is 0x123f, something like that, right? So this address that it returns, we can save it so that we can know how to refer to that box. So this is the address of where this box lives or stays. That's the address. Then we stored that address, right, by using the assignment operator or the equal sign and stored that address inside this pointer. So therefore, this address over here will now go into this box. So this address goes into this box. So therefore, the pointer stores the address of where that box is stored. I hope it makes a lot of sense. So that's why when I try to output this, I'm going to see an address. So if I remember pointers, if you use the pointer, the name of the pointer without the star, then you're actually referring to the address. So the part that I've highlighted refers to the address. So if I want to see the address, I have to say cout number. This will output the address of where that box is stored in heap memory. But this is wrong because we haven't deallocated. We'll get to that. So you see, there's the address. Me, I was just making an example here. This address here is just an example. This is literally the address in the computer. This is the actual address that you're seeing here. So that's the actual address. So that address, right, as you can see it, I can point and go into the box to see what's inside the box. But then remember, I didn't give the box a value, a default. I didn't assign it or initialize it, the box. So therefore, I'm going to get some random value. So I'm going to dereference and say point to that address number. Then I'll put what's stored inside that address or inside that box, which is some random integer. See, it's a very big number. It's 17,242,000. It's a very big number. If you want to assign this box a default value, I think the only way I'm not sure about the Kelly braces. I'm not sure about Kelly braces. Let me try Kelly braces. Oh, Kelly braces do work. So this is this part, right? Remember, I talked about the different ways to initialize a variable. So you can use the round brackets here or use Kelly braces so that this box over here, it doesn't have a random value. It has a value that we know of, right? So let's say I use Kelly braces. I'm most likely going to use Kelly braces. So I'm going to initialize it to 10. So now this box on the heap memory over here is going to have the value 10. So I'm going to do this and say 10. So now this box is the number 10 inside of it. Then we get back an address of where that box is stored in heap memory. Then we store that address inside this pointer. So now the address might change or remain the same, doesn't really matter. But the value now, the answer here, we know what the answer will be. It's 10 because we gave it a default value of 10. So if I try to build and run this, it should work. So let's see. Yeah. See, magic, right? There's 10 because we gave the box a default value. This will be the syntax for giving that box a default value. Then you can change the value if you want to, because remember to refer to the box, right? We have to get the address, which is stored in the pointer's name, then point to or go to that address, which will basically go inside the box. Then I can say inside the box, change it to 200, something like that. This is how I would change or update the number, right? Or update the number that's inside the box without even having to set a default value there. Or I can set it and also change it. It's up to me. Doesn't really matter. And then now you'll see that my output is going to be 200 because I put 200 into the box. So you see, it's 200. So I'll just undo this for now, right? And put this back here. I'm gonna leave it with the default value 10. So it has the number 10 inside. Then now, remember what I talked about. The heap is like your parents' place. You are told to do everything on your own. You complain about hunger, they'll tell you go cook. So you are doing the cooking. So everything is done by you. So that's the heap. So if you allocated, deallocation or deleting must be done by you too. So I must delete because I'm done using this box. So to delete, it's simple. You just use the word delete, right? That's how simple it is. That's how you deallocate. You're gonna say delete, right? Delete where, so you need to pass in the address of that pointer, right? Which is just number. So what C++ does, right? It's gonna go look for a box that is this address and delete the memory allocated for it. So basically that means this 10 will be destroyed. It will go back to just being an empty box. But then I want you to notice something here. We did delete the box, but our pointer is still pointing to that box, which is an empty box. So we need to cut the code or cut this connection here. You see here, it shouldn't point to that same box because there's nothing in the box. Another way to think about, okay, let me picture it this way. Another way to think about deleting, right? This line of code over here. It deletes the number inside the box. It removes everything inside the box. Removes the label. If there was a label in the data type, everything gets deleted. Then it deletes the box itself. I want you to picture it in this way so that you see the problem with leaving things the way they are. You see, if I leave it here, this arrow, basically my pointer here is still pointing there. So that means if I try to dereference, you see this is what you see this when you take a pointer and then you point to that address, this part over here, we call it dereferencing. That's basically getting the value inside the box using that pointer. We call that process dereferencing. So we need to, what if the user tries to dereference? Basically, they try to see what's inside the box, but there is no box here. So we need to prevent the user from doing that. But let me show you the problem. So after deleting, let me do spiritual things here. Let me try to go inside the box again. I know there's this line over here, which already deleted or removed the box. So you'll see that your most of the time your code will just jam, right? Or sometimes it might work, but it should jam. No, not there. Let me do this. Let me say number is equals to 20. Let me try to change it. But then remember, there's no box anymore. Yeah, you see now it crashes. So yeah, it's now crashing properly. So you see, if I try to change after deleting, you see, it's no longer returning 0 here. Remember, here it should return, when it returns 0 here, that means everything went well. Is there 0 there? No, there's a negative number. So that means something went wrong. But C++ doesn't know what went wrong. So if you want C++ to tell you that something went wrong, you need to cut the cord, cut the connection. Remember, it's still pointing to nothing. It's still pointing to the heap memory, of which there's no box anymore. So we have to tell C++ that, listen, this should now point to an empty space, basically to nothing, because there's nothing in there anymore. How do we do that? We basically tell C++ to point to null pointer after deleting. So we're going to say, go to that address, right? This address. Then change the address to point to a null pointer. By null pointer, to be honest, and the implementation of null pointer, right, is basically zero. Basically means that it's going to point to nothing. So that means my pointer will now point to this, which is just null pointer. Basically nothing. So that if we try, you see that I'm no longer pointing inside the heap memory. I left the heap memory. So that now if the person tries to dereference or to go inside this box, you will get an error that will be easy to understand that you're trying to access a box that does not exist. This error is called a segmentation fault. So if you see this string in your terminal, right? This string, this means that you are trying to what? Access a box that was deleted. That's what it means when you see that error. So that's why we always set it to null pointer or basically zero. Don't initialize, don't set it to exactly zero. Don't do this. Just set it to null pointer. But just know it means technically setting it to zero. Remember, zero represents nothing. If you're a deep thinker, if you can think critically, zero represents nothing, right? For example, I have 0 eggs. That means I have no eggs. So null pointer is basically zero, which represents that the address should now point to nothing. So that if you try doing spiritual things like this, right, you see here, we should get an error called segmentation fault. So let me try to build and run. It should show, okay, this part doesn't show, but if you run it using the terminal, let me show you. Let's see if I still have G++. I think I have it. Yeah, I have G++. So let me open the terminal. Let me go to my project. If you use the compiler, just like in the preg, agree you saw in the preg that there's a bonus question for your preg. That bonus question, it forces you to go learn how to install the compiler, C++20. I have that compiler, so I'm going to try to use that to show you that it will show me that segmentation fault error that I was talking about. So now I will know that, oh, I'm trying to access a box that does not exist. So now I will know my error. So this will be g++ main.cpp, right? So I call the translator called G++, who's going to translate my C++ code to the mother tongue of the computer. Remember, the computer is like a Zulu drive, very stubborn. It only speaks its home language. So I have to translate C++ to the computer's home language every time I have to run it. So I'm going to say -o, right? Because I want to rename the file that's going to have the translated language. So I'm going to call it main, right? And then enter, right? Then it's going to create an executable. You see this main.exe, right? This is the language of the computer. There it is. So you see how hard it is? It's complicated, right? That's why we code in languages like C++, because to code in the home language of the computer, it's hard, it's complicated. So I'm going to say main.exe, right? To run it, it might crash. Yeah, I thought so. So let me say dot, yeah. It's not working is nice. No, it's not working nice. Let me open that thing. What is it called? MSys2, right? This, yeah, I think this one. Yeah, I think this is the app I have to run. Yeah. Yeah, just give me a minute. I want you to see the error. Like if you don't have the right compiler, it's not going to show you that error you're supposed to see. So that's why I'm trying to show you this error so that you don't think I'm lying. Um, And then this represents a different operating system. So instead of backslashes, we use forward slashes here. The terminal that I'm running, right? It's like I'm running a terminal on a MacBook. That's why things are a bit different. So I have to use forward slashes instead of backslashes. Then I'm gonna use ls to list everything in the folder. Then I'm gonna run main.exe or just main. So ./main. Yeah. So you see what I was talking about, the segmentation fault. There's that error. But you see how hard it is to find it. Code blocks won't tell you, but if you use the right compiler, that's why, to be honest, using a MacBook to code is way efficient than a Windows. Because you see, if you were on a MacBook and installed the compiler, then this would show this error, which is a very clear error. It tells you that a segmentation fault has occurred, which means that you are doing stupid things. You're trying to access a box that does not exist. Basically, you're trying to access a pointer that points to nothing or null or zero. Basically points to nothing, of which we did that. Look at here. That's what we're trying to do. We're trying to do spiritual things. So this code over here won't run. It's going to cause your code to crash. So here we get a segmentation fault. The reason why, that's why we use null pointer, so that we get this error if we try to do things that are illegal, like accessing a box that's already deleted or removed. It's no longer existing. It's deleted. It's gone. So what are you trying to do over here? So the compiler tries, Shem, even though it doesn't speak English, but it tries to say, okay, segmentation fault, you have to use your common sense and understand what segmentation fault actually means. So yeah, I hope this is very clear. You understand this. You understand pointers very well. Then now, if you wanted to create what we call a dynamic array, right? Which is basically an array that can, basically your array can be of any length. You need to use pointers. You need to, not pointers per se, but it's still pointers, but not really pointers, but you need to use the heap memory. Remember what we talked about here. Here, I'm just initializing one value for one number, but I can actually specify square brackets here to say that I want multiple values inside one name, which is basically telling C++ that you want an array, but then the array should be created on the heap memory. But then I want you to notice something. You see in between deleted number, I didn't specify the square brackets, right? Why? Because before I only had this, which is just one integer. So for one integer, you don't have to specify brackets here. But the moment I put in a size here, and then I specify the number of elements, let's say 10. I also, when I delete, I need to update my deletion. I need to put in square brackets like this, empty brackets, to tell C++ that go delete the memory for this thing or for this whole array. Delete the whole array. That's what this means. Because now I have more than one value, which is basically an array. So I need to delete the whole array by repeating those square brackets, but I leave inside of them empty. Why am I leaving? Why is the insides of the square brackets empty? Because I want to empty out the array. Basically, to delete everything. So that's why this is the syntax over here. Then remember, this is an array, right? So you use it as a normal array. So I can say cout the number at position 0, cout the number at position 1. Remember, we didn't initialize the numbers. They are random. So it will just output random numbers. So you see, there's a random number, which is this number, then 0, then also index 3 or 2, all the indexes, that's up to you. So now we've actually created a dynamic array, basically an array that can take in any number. To prove it to you, right, I'm going to ask the user for input. I'm going to say cout enter number of values. The user is going to enter the number of values in that should go in the array. Then we're going to store it inside the variable length. So int length, I'm going to initialize it to 0. Then I'm going to use cin to get the input or to get the length. Then I store it inside the length variable. Then here, when I create my pointer, instead of passing 10, because if I pass 10, it will be what I call a fixed array, meaning it is one size, it's fixed. But we want it to be dynamic, meaning that it can be any size. So let me show you. If I run this, if I build and run, and then enter the number of values, if I enter 900, my array actually has 900 values. It's of length 900. If I enter 5, right? Let's say we enter 5. There's going to be 5 elements in the array. So that's what we call dynamic. That means the array can be of any size. So this is how you'd create the array. So it's still the same thing. Remember, use the keyword new. So it's going to create this array on the heap memory with all the indexes. I could try and let me try and do the diagram, but you see that the diagram will actually become very big and complicated. But let me try to do it so that you guys can understand. But I doubt no one, there's someone who doesn't understand. Because this is a very simple way of picturing it, the way I made it. But remember, each of these boxes, they are stored in a specific index, right? So um, okay, let me see if we can fit here. So these are the boxes, right? So I'm gonna copy, let me do this, right? And then I'm gonna copy this, paste it next to here, and then paste this next to there, right? So these are the values, this is the array itself. So when you use new int and you give it a length there, right? It depends on whatever length it is. So let's assume that the user entered length 3. That means it's going to create an array of 3 numbers. Then as usual, each number has its position, if you still remember. So this will be position 0. And remember, we talked about arrays that they start counting from position 0. Unlike us human beings, we start counting from 1. This will be position 2, right? So that's why when I access this array, and now the address, right, it points to the address of this array, right? So I'm gonna point somewhere here, right? So it points to this whole array. So you get an address. So here it creates that array, then it returns an address of where that array is stored or a pointer to that array. Then we store that pointer or that address in our pointer. Then we use it as a normal array because it is an array. Then once we are done, we delete all the elements in the array. How do we do that? We need to specify these empty brackets so that we tell C++ that to remove that length, delete everything that's there. Then we set the pointer to null pointer, basically to point nothing, because that array is no longer existing once we delete it, right? Because that's what deleting means, right? For example, if you delete a file in your computer, it's gone, right? Or in your phone, you delete an image, it's gone, right? So that's the same thing. So we're gonna delete that box or that array. Then since it's no longer there, there's no need for us to keep pointing to that array. So we're gonna point to nothing or to null pointer. I hope the arrays are now clear, right? Then let me talk quickly about if statements. Yeah, there's quite a lot, but then it's fine. We'll take our time. There's quite a lot to explain. So we have what is this? What do I need to explain? If statements, right? So with if statements, right? What are if statements? If statements, they allow us to check to do something when a specific condition is met. We call it a condition. By condition, it means that if you do if this thing is done, then we do this. For example, it's that imagine you're in a relationship, right? And then your partner says, if you get 100% for this week's practical, I feel like that you guys should normalize doing that, especially if you're in relationships. You tell your girlfriend, okay, if you get 100 on your prac this week, ne, I'll take you out to Roko Mama's. something like that, right? So obviously the condition is that you must get 100% for the prac. Then, only then, once you get the 100%, I take you to Rocco Mamas, right? Once you get that 100% for that prac, for that week, any week, it can be any week. So this would mean that the condition that needs to be met is get 100. Then, if the condition was met, they take you out to Rocco Mamas. So that's basically what we're trying to do with if statements. We're trying to check if this condition has been met. If it has been met, then do something. So if it has been met, right, this is where we introduce the data type bool, right? There's this data type called bool in C++, which is going to allow us to work with if statements. So bool, it works with only two values, true and false. And this bool, right, you might ask us, you might wonder why are they calling it bool? Because it was invented by the mathematician called George Boole. So they took his surname, this one, then they removed E, then they used a small letter B like this, right? Then they came up with the data type bool to name it after him, right? For the discovery that he had made. So if you don't like logic, we're talking about the same logic, the logic you did in maths. You should have done logic by now. So that same logic applies here. If you remember those truth tables, yeah, that's what I'm talking about, that topic. If you don't like it, you're going to be forced to like it because you can't understand if statements if you don't know logic. So if you remember logic, right, we have these operators. We have and, or, not, and then exclusive or, right? We have these four. Logical, they're called in C++, right? We have symbols that represent them. The symbol for and in C++ is two and signs. Then the symbol for or is the two pipes. So this is two line. Then this is not. The symbol for not or negation is the exclamation mark. Then the symbol for XOR, basically exclusive or, is this symbol over here that looks like it's facing up, like a sort of it's almost a triangle, but yeah, this symbol. So these are the symbols you'd use in C++ if you are referring to that specific thing from logic. If you are referring to and in logic, you use these two symbols. If you want to refer to or, you use these two symbols or those pipes. If you want to negate, right? Basically, remember negation, this is the opposite. If you have basically not, okay, let me do this. Not true is basically equals to false, right? And then not false is equals to true. That's truth tables. Then and, right? If you remember in maths, they like to use if and only if. If you still remember, we're doing revision for maths here. They use these keywords, right? If and only if, right? So this returns true if and only if both statements, not statements as such, both conditions are true. So that's the only time it's true. When both conditions are true, both. So that means both conditions need to be met. For example, you tell your girlfriend, I'll buy you chocolate if you get 100% for every practical and you qualify to write the semester, the exam. So you see, there are two conditions that need to be met. Number one, you need to get the 100% in every practical and qualify for the exam. So if you meet those two conditions, then you can get chocolate. If you miss them, then yeah, no Ferrero Rocher for you. Then the or, right? This one is a bit lenient, right? It's a bit it's like the person, it's like you have a partner who's a bit kind, right? A bit more understanding. You'd be like, hey, matter practicals, I know the practicals, hey, they're hard. So I'm just gonna say or, okay, if and only if one of the, yeah. So with or, right, it's true if and only if one of the conditions is true or one of the conditions are true. So at least one, right? Even only if when at least one of them is true. So for example, You can either get 100% in every practical or qualify for the semester for the exam. So that means if your partner fails to get 100% in every prac, they can still get the chocolate because they're gonna qualify, right? Because they used or. Or means one of them need to be true. So yeah, and then negation is just negates the statement. Basically, it tells you the opposite. So for example, if you say not, right, of let's say some statement or sentence. Let's say your sentence is I am great, right? And then you're negating that, which means that you're saying you are not great. I am not great, which is the opposite of saying I am great. So it's negation or the opposite. We are getting the opposite of that statement. So that's what not means. Exclusive or it's true if and only if the conditions um basically it's true and it's true if and only if um both conditions, right? So both the conditions have different we call them truth values. Go back to your slides for maths 1A or whatever. If you're extended, go to the slides, go look for the slides for logic. You'll understand what I'm talking about. When they have different truth values. Truth values, it's the key is the true and false. They're called truth values. So it returns true. This is called exclusive or, right? So in full, it's called exclusive or, right? So it still works similar to the or, but then the events are mutually exclusive. Meaning that that's why the definition says that you get true if and only if both the condition have different truth values. So if you have true, false, false, true, that's when it's true. But if they are the same, then it's false. So that means exclusive or it's a rare, you already use it, but exclusive or is used when you have two conditions that cannot be the same. They cannot, basically two events cannot occur at the same time. Basically, you cannot be failing, you cannot fail the module and become a top achiever. If you get what I'm saying, those two events are mutually exclusive. They cannot exist simultaneously. So that's what exclusive or checks. It makes sure that two statements or two conditions, they're different. So yeah, I hope I've explained quite a lot. So now we understand logic, right? Then we have what we call relational operators, right? Relational operators. And we talked about relational operators. These are straightforward. We have your greater than or equals to. It just means greater than or equal to. Then we have less than. It just means less than. Then we have greater than. It just means greater than. Then we have what else do we have? We have equals to. We just checks equality equals to. It checks if the value on the left hand side is equals to the value on the right hand side. And then we have the not equals to, which is basically an exclamation mark and an equal sign. One equal sign. Then this will be not equals to, right? So this will be the relational operators. Okay, I'm not done. I forgot to put less than equals to. So there's also the one for less than or equal to. And all of these operators, right? Both the relational operators and these are called logical operators. Both because we deal with logic, so logical, because we're dealing with logic. Relational, we're checking if two things are related, meaning are they equal, is one greater than the other, and stuff. All of this, they return a value of type bool, basically a boolean. Then now, since we understand all these operators, don't worry, I'll make notes on this and then create a PDF and send it to you. So we have all these operators. So now we can understand if statements. So if statements, this is the syntax for if statements. So if statements, you're going to say if some condition is true, right? Then you put curly braces. These curly braces define what we call scope. So what is scope? Scope, you can think of it as like a range in a function. That means if you have a number that belongs to that range, it only belongs to that range. You cannot have a number outside that range, right? Because that's how ranges work in maths, right? If you still remember, ranges and domains, that's how they work. It needs to be within those bounds. So these curly braces, they define those bounds. We call it scope. So this part defines the start, right, of the scope. Basically, the start of the if statement. Then this part defines the end of the if statement. I can show you scope inside C++ now. Let me show you. So after here, right, I'm gonna explain scope. So to define scope, we just simply put curly braces. But then if you only put curly braces, right, that means this code will run it would always run, it will always run. You don't need to run it based on some condition. It just runs. So let me show you. So if you create a variable here, int x, initialize it to 10, then you see out value of x, right? Then you say see out that value x. Then you put an end of line character, right? There's the code. This will work, this will run because C++ will go back to the top. Then it will realize, oh, this is where the start of the scope, and then this is where the scope ends, right? Basically, if you declare anything within the scope, within this curly braces over here, you try to use it outside, crash. So let's run it for now to try to see that the code will run. So let me say 10, whatever. But then you see, it always runs without, it doesn't check any condition. It just runs. That's how we define scope. Then if you try to use a value outside, let's say try to say output X, C++ is going to be like, that's interesting. Where did you get this X? Because this part over here, the code inside of it belongs, it belongs starting from here and it stops existing from here. So that means the moment you leave the scope, that variable X no longer exists, especially if you declared it within the scope. So let me try run it. You see that you're going to get an error. You see, there's that error. So if I view here and I go to logs, right, to check what that error says, hopefully the error is clear. Let's see. Yeah, X was not declared in this scope. You see the word scope, which is 100% correct what the error is saying. Because X was not declared in the scope. What scope is C++ referring to? The scope. You see there's a starting curly brace there. It's going to check, is there any variable named X there? No, it's not. This is a different scope over here. You see this part over here, starting from line 18 to line 22. This is a different scope. Then the scope ends there. So it didn't find the variable X. It didn't find it. So that's why this line of code will crash. So I hope that now makes a lot of sense why we need scope. So this will crash. Then, okay, let me check this notification. Oh, just received payment. Let's continue. So this part will crash. So that's why I'm just gonna leave it as a comment. So there we've defined scope, but what if the scope, whatever is inside the scope, right? Do you see that it's code? You see that, right? So whatever we've defined inside the scope, it's code. But what if we only need to run this code based on some condition? For example, I get when before you go out, you're gonna check if it is raining. Then if it is raining, are you not gonna grab an umbrella? You will, right? But you only take the umbrella when it's what? Raining. So that's why our if statement will look like this. If is raining, right? Then you define the scope for the if statement. Then if it is raining, then you should what? Take an umbrella. but it'll only, this if statement, right? It will only execute this part. Basically, it'll only give you an umbrella if it is raining. Basically, if is raining variable is equals to true, meaning it has the value true. If it has the value true, meaning that it is true that it's raining, then you'll get the umbrella. So this will be an if statement. But what if we want to, what if it happens to be not raining? That's where we put what we call an else branch. So I'm going to say else, meaning it's false. That means it is not raining. If it's not raining, then it should be sunny or windy. It could be windy, but let's just assume it's going to be sunny. The sun will be out. Then wear shorts. So if it is indeed raining, take an umbrella. Else, meaning that when it's not raining, wear socks or shorts, I mean. So that's basically how an if statement works. If you wanted to check other conditions, for example, it is windy, you can do what you call else ifs, right? So that's when you can say else if to check another different condition. The condition needs to be different from this condition over here. It needs to be unique. Then you can just say if is windy is equals to true, meaning it is windy outside. If it is windy, then let's say you don't like the wind, you're not a fan of the wind, then you decide not to go out, then don't go out. So you stay indoors if it's windy outside. But what if it's not raining and it's also not windy? The else still needs to be there. So else curly braces, then you just let's say if it they are used, let's assume it's gonna be sunny. If it's not windy, if it's not raining, then it's sunny. There's also cloudy, but if it's not raining, so it shouldn't. Okay, it might be cloudy even though it's not raining, but that's not the point. I just want to explain if statements. Let's assume that it's if it's not raining and it's not windy, then it's sunny. Then I'll wear my shorts because it's sunny outside. Then the if statement will run and check every condition until it finds the condition that's true. If it checks here and it sees, oh, this is false, it won't run it. That means you won't take the umbrella. If it checks if it's windy. If it's not windy, that means you do ignore this thing of you staying indoors. Then it'll check the else because it was none of the above. So the else just basically means none of the above. So let's make a simple app, right? So let's say you have int marks, you have marks for your practical, I don't know, maybe your semester mark is 49, right? We're trying to check if you qualify for an exam or a sub. So yeah, this could be used if you don't study. So, and you don't do the homework. So I'm gonna say if marks, I'm gonna check the in what range is the marks. So if marks is greater than or equals to 0, right? If you want to write like something like this, right, in C++, this is how you write it. Let's say you want to check if it's between the range 0 to 49, right? You want to check if it's in this range. Look at the square brackets. It's inclusive. It includes 0 and includes 49. That's why I use greater than or equals to. To translate this into code, you say you take a variable, you check if it's greater than or equals to the lower bound. Then you use the and to say and because both conditions need to be met. So the number needs to be at least greater than 0. And that same number needs to be less than or equals to 49. Because for it to in order to be in that range. So this code this condition that I've written there, it translates to exactly that. So if it's within that range, right? That means you don't qualify, right? So I'm gonna say cout. Sorry, try again next year, right? And then I'm gonna put in a new end of line character, the \n. So if you didn't, if you got your marks within this range, it's gonna output, sorry, try again next year. Because you failed. You didn't qualify. You need at least 50 to qualify. Okay, it depends on the module, but you need at least 50 to qualify. And then you can have else if to check a different range. So what if it's between 50? Okay, you can either qualify or you don't. So sorry, you do not qualify, try again next year. Sorry, you do not qualify, try again next year. Then I don't need to do an else if. Why don't I need to do an else if? Because there's only two possible conditions. You can either be in this range or your number can be 50 and above to infinity. So it's from 50 to infinity. So that's just else. That's just simply translates to else. So I can just say else, then I'm gonna say see out, and I'm gonna say congrats, you have qualified to write the exam. Then I'm gonna put a \n, which is an end of line character. So this is the if statement, right? Now I'm gonna run it. It checks the value of marks. So this is what's gonna happen behind the scenes, right? Let me show you what happens behind the scenes. It's gonna go to this box with the label marks and take what's inside the box. What's inside the box is 49. So it's gonna say, is 49, it's gonna ask that question, is 49 greater than or equals to 0? If it's yes, then it's gonna return true. So this will just be true, right? Then it checks, is 49 less than or equals to 49, which is true. So this will be true. And this is an and. Imagine it's like an and there. Then you think about, then you refer to logic. And true is what? True. So the overall result will be true. Then it will run this. So that means it will say sorry, you didn't make it, because it is true that 49 is within this range. So I hope that makes a lot of sense now. So I broke it down so that you see how C++ handles it. So now I'm gonna build and run. And then I'm just entering a number. So you see, it says, sorry, you do not qualify. Try again next year. So it means you're gonna repeat the module. So yeah, this would be examples of if statements, right? And you can combine and have multiple else ifs here, as many as you want, but just make sure, don't you forget the round brackets. The conditions are placed inside round brackets. You forget that the error crash. C++ has no sympathy for you forgetting syntax. It has no emotions. It's not gonna feel your emotions. You crying that it should give you a chance. Doesn't care. Doesn't matter to C++. So this will be if statements. Yeah, as I noticed that there's quite a lot to explain. We'll cover the other things in the next session because I can't explain switch statements now. It's gonna take a lot of time. I don't want to rush things and end up moving too fast for you guys to understand. So this will be the diagram. I'll share it in the group, this diagram. So that's it for today's session. I don't want to bombard you or give you guys too much information. So I'll just stop recording now.